Hello class, today we're going to be talking about the real number system. So the real number system is a way for us to kind of group numbers together, see how they're related, see how they're different, but it's just a way for us to categorize numbers. You'll see here that we are talking about irrational numbers, natural numbers, whole numbers, integers, and rational numbers. So real numbers include several subsets of numbers, including and subset means it's a small part of a larger group of numbers. I think an easy way to think about subsets is just, say for instance we have Graham Park as a whole. A subset of Graham Park might just be the 8th grade. And maybe a subset of the 8th grade could be Miss Leidy's class. So even though you're an 8th grader, you're still part of the larger school itself. So that's one way to think about subsets. So we have our natural numbers. These are your counting numbers. This is where you would naturally start counting. So if you wanted to count something in front of you, you would start with the number 1, right? So these are the numbers 1, 2, 3, 4, all the way to infinity. We have whole numbers. These are going to be our natural numbers as well as 0. I guess I forgot to write 0. So that includes 0. These are numbers or values that you can have in your wallet. So think about amounts of money that you could actually hold. You could have $1, you could have $10, you could have $30. If you're broke, you could have $0. But it's still something you'd actually be able to hold. Integers are where we're taking all the numbers we would see on a number line, meaning positives and negatives. You wouldn't normally see decimals on a number line, so we're mostly just talking about positive and negative whole numbers. Next, we were talking about rational numbers. These are all numbers that include fractions, repeating decimals, and terminating decimals. So you can think if it's a ratio, you can write it as a fraction. Repeating decimals, these are decimals that have the same number that repeat itself over and over. It is symbolized by that, line over it. So if I had 0.3 repeating, that means the number goes on and on and on and on. So an example could be that. It could be 0.45 repeating forever. It could be 0.111, all of those repeating forever. Terminating decimals are the opposite. These are decimals that end and don't have a pattern, which means I could have like 0.5. Or maybe I have 0.111 with no line, right? Because it ends. So that's another difference between those two. So next we're going to start classifying these numbers. So we need to use our definitions from before. So I need to figure out which subsets these would fall into. So as an example, I know 0. If I'm counting, I'm not going to start at the number 0. I'm going to start at the number 1, which means it's not natural. It is a whole number, though. I'm just going to write letters instead of the actual names. You guys are more than welcome to write the names. It's a whole number. So a shortcut is that because it's a whole number, you'll notice this whole number box is inside the integer box, which means it has to be an integer. And that integer box is inside the rational numbers, which means it has to be a rational. Next, we're talking about 6 over 3. So be careful. Some of these look like weird fractions or weird square roots, but I know what 6 over 3 is, right? 6 divided by 3 is 2. And 2 is a natural number. Because if I counted, I would eventually get to the number 2. Because it's natural, again, it's going to be a whole number. Because it's a whole number, it's going to be an integer. And because it's an integer, I definitely know that it's rational. So a trick would be figure out the most specific box you can put it in, and then if it's in that box, it's going to be in all the different boxes. Same thing with the square root of 225. The square root of 225 is actually 15. Because it's 15, it's going to be a natural number. And because it's natural, it's going to be everything else. Some of these are only going to have one category. This is not a natural number. It's not a whole number either. It's not an integer because it has that decimal part, so it has to be rational. Same thing with a fraction. If I can see it as a fraction, and I can't reduce it or anything like that, it has to be rational. Same thing with decimals. This is a repeating decimal. I know that because it has the line over top of it, because it's a repeating decimal. It has to be rational. So you're thinking, all these are rational, right? Nope. You got things called irrational numbers. So irrational numbers include non-terminating / repeating decimals and imperfect squares. And we just talked about imperfect squares. So that ir in front, IR, means not. So say if someone was irresponsible, they are not responsible. So this just means all the numbers that are not rational. So here I have a decimal. So I know it's going to be rational or irrational, but we have to make sure this decimal doesn't go on forever. It doesn't. It's terminating, right? So because it's terminating, it's rational. But the next one looks exactly the same, except it has these 3 dots. Those 3 dots tell me that it goes on forever and there's no pattern. Because it goes on forever and there's no pattern, irrational. Square root of 25, it looks like it'd be irrational, but I know what this is, right? That's 5. Because it's 5, it has to be rational. But the square root of 5, that I don't know. I mean, I know it's between 2 and 3, but it is irrational. I should have thought this through. Irrational. And then if I can write it as a fraction, I know it's going to be rational. And I mean, this is a natural number, right? If it's a natural number, it's going to be everything anyway. So this is also rational. So I want you guys to work on this next section on your own. We are going to come back as a class and we're going to talk about it. But for this one, I want you to use the chart, use the definitions on the previous slides, and I want you to tell me which subsets do these numbers belong to.